Hi everyone. In this video, we're going to be talking about functions. So functions are something that we've seen in our high school math classes, but depending on how comfortable you are with functions, we may need to look at them again to help us be successful in calculus. So the way I like to think about functions is like a mathematical machine. So let's think about one of the machines in a standard household, a washing machine. So the function of a washing machine is to clean clothes. So we input dirty clothes into the washing machine and we output clean clothes. So you can see that here in the picture on the left, right? So the function of the washing machine is to wash clothes. If we put that same input of dirty clothes into another machine in our household, such as an oven, well, our input would be dirty clothes, but our output would be burnt clothes because the function of an oven is something different. So whenever we are given a function in math, we should think about it as, okay, what is the point? What is the function of this function? And we can kind of break it down in that way and think of, okay, what operations does this function tell me to do? So for example, the washing machine, that function tells me that I'm going to mix soap and water and move the clothes in circles until they're clean. The oven just outputs heat onto the clothes and then they end up burnt. So why is understanding functions important to us? So one of the main things that we're going to talk about in calculus is the derivative, which allows us to model how things change over time. So a derivative is going to be related to a rate of change, which is going to be related to a slope. And this is one of the main things we learn in calculus is how to compute a derivative. And we compute these derivatives by looking at a specific function evaluation called the difference quotient. And in order to calculate the difference quotient, we need to be really comfortable with evaluating functions. So let's look at some examples of evaluating functions, starting by looking at this function, f of x equals 3x. So like I said just before, one way I think that is very helpful to think about functions is what operations does this tell me to do? So this function takes our input of an x and we say, okay, our output is that x multiplied by 3. So whatever our input is, our output is that same thing multiplied by 3. X becomes 3x. So we can evaluate this function at different values. So let's look at this list here. So if we're evaluating f at 5, we just take a 3 and multiply it by 5 to get 15. If we are evaluating the function at pi, we take our 3 and multiply it by pi to get 3 pi. If we're evaluating our function at pi over 2, again, we take our 3, multiply it by pi over 2 to get 3 pi over 2, right? So this is a more standard way to evaluate functions that you may have been more familiar with based on your classes in high school. So where things become a little bit tricky is whenever instead of inputting a numerical value into our function, we instead have a different variable or a combination of variables. But with this function, no matter what the input is, we're defining this function to multiply that input by 3. So let's look at f of y. So if our input is y, our output is 3 times y. If our input is delta x, our output is 3 times delta x. And so delta x may be a new variable for you, but it's going to be one that comes up a lot in calculus, just because, like we said, a derivative is a rate of change, and delta is our mathematical notation for change. So this is going to come up quite a lot whenever we're computing derivatives. So this delta x is one variable. It's not a delta times an x, but it's all one variable. So if you need help remembering that, one thing I do is I tend to put this delta x in parentheses so I remember that I'm never going to split apart my delta from my x. This variable represents the change in x, and so it's all going to be together. So next, if I'm evaluating the function on x plus y, I have 3 times x plus y. And if you'd like, you can go ahead and distribute this 3 to become 3x plus 3y. And lastly, if I have 3x over y, I just multiply 3 by my input of x over y. And again, I'm going to just multiply straight across for my fractions here. So as you can see in all of these examples, no matter what our input is, our output just multiplies that input by 3. And so this function is a little bit more simple. So let's take a look at a more complex function. So if we're looking at the function f of x equals x squared, this function takes our input of x and our output is that same input now squared. So again, we're going to evaluate this function on these same values. So this function evaluated at 5 is 5 squared, which is 25. This function evaluated at pi is just pi squared, and there's no way to simplify that. And then f of pi over 2, I'm going to take my pi over 2 and put it in parentheses because I'm squaring this whole thing. And then I can distribute this exponent over this division. So this is going to be pi squared over 4. Okay, so again, each of these outputs are just the square of our input. So again, let's replace x, and instead of evaluating this at specific values, let's evaluate it on specific variables. So f of y, we just square our input to get y squared. Delta x, we just take our delta x and we square it. And again, I would recommend putting this in parentheses so that way it doesn't look like delta times x squared. F of x plus y, we're just going to take x plus y and square it. And one thing I want to point out here is if you're going to simplify this, remember that we need to FOIL out this multiplication. So squaring is just multiplying the same thing by itself. So whenever we multiply our first, our outside, our inside, and our last, we're going to get x squared plus xy plus xy plus y squared, which is x squared plus 2xy plus y squared. So just keep in mind that we can't distribute that square over the addition. So we need to actually FOIL it out, and we're going to get something with 3 terms here. And lastly, if we are evaluating this function on x over y, this is x over y squared. And just like our pi over 2 above, we square the top and we square the bottom. And this is how we write this. So it works in a similar way. Whatever our input is, our output is that same thing squared. So we talked earlier in the video about why function evaluation is important. And it's important because of what's called the difference quotient. So whenever you get to talking about derivatives in your course, you're going to have to look at these 2 fractions. So we have one difference quotient that has x and delta x, and we have a second difference quotient that has x and c. So that we're going to start off calculating derivatives by calculating these difference quotients and then doing what's called taking the limit of them. So we're not going to concern ourselves with taking those limits now, but what we want to do is we are going to just practice writing out what this fraction should be. So first off, we're going to start off with f of x equals 3x, and we're going to compute these difference quotients. So remember, if my f of x equals 3x, when I'm starting off by looking at f of x plus delta x, all I'm doing is I'm going to take that x plus delta x and I'm going to multiply it by 3, because this function tells me I take my input of x and my output is just 3 times my input. Okay, and then if I'm just inputting x, then my output is 3 times x, and then I multiply by a delta. I divide by a delta x. So in order to calculate these difference quotients, we're going to need to simplify this. So to do that, I am going to distribute that 3. And then what we're going to notice is that on top, we have some like terms that we can cancel out. So we can cancel out a 3x on top and bottom. And then we're going to be left with 3 delta x over delta x. And we can cancel out the delta x on top and bottom to just end up with 3. So whenever we're calculating these difference quotients, we'll see time and time again that something similar will happen no matter what difference quotient we're calculating, that we're going to have some cancellation in our numerator that will allow us to cancel out a delta x on the bottom. Next, we're going to look at that second form of the difference quotient. So we're going to look at f of x minus f of c over x minus c. So again, my f of x is going to be 3x. My f of c is going to be 3c. And I divide that by x minus c. And again, we're going to want to simplify this. So I notice that on top, I have a common factor of 3. And then I'm left with an x minus c on top and bottom, which are going to cancel out to just leave me with a 3. So again, we noticed that these difference quotients gave us the same number, and they should look somewhat similar. So in this case, they're exactly the same. But this is how we're going to calculate our difference quotients, and this is why we need to be comfortable evaluating functions. So next, we're going to do the same thing, but with that second example of f of x equals x squared. So remember, whatever our input is, our output is just going to square it. So my first function evaluation of f of x plus delta x is going to be x plus delta x all squared minus x squared divided by delta x. And then again, I need to simplify this. So if I am going to FOIL out x plus delta x, I am going to get x squared plus x delta x plus, and I'm going to go back and put that delta x in parentheses just to be super clear. So that's my first, my outside, my inside, and my last. Then I subtract my x squared all over delta x. Okay, so again, I noticed that my x squared on top and bottom are going to cancel out. And now on top, I have a common factor of delta x on top. So I'm left with an x plus a delta x all over delta x. And I noticed that these delta x's can cancel just like they did in our first example. So I'm left with 2 x's and a delta x. Okay, so if you need to go and write down off to the side as scratch work what this x plus delta x squared looks like, do that. There's no shame in needing to write down these extra steps just to make sure you don't make a mistake. So I'll do it over here. So our first is x squared, our outside is x delta x, our inside is x delta x, and our outside is delta x squared. So if you need to write this off to the side, do that. It's much better to write out more work to make sure we're not making a mistake in our arithmetic. Okay, so now let's do this second difference quotient. So f of x is just x squared, f of c is c squared, and then we have x minus c on the bottom. So just like before, we're going to need to simplify this, and our goal is going to be to factor out that denominator so that we no longer have a fraction. So on top, I notice that this is a difference of squares, so I can write it as x plus c times x minus c divided by x minus c. The x minus c terms are going to cancel, and I am left with x plus c. So these look a little bit different. So now this 2x plus delta x and the x plus c aren't the same, but they are similar in the fact that it's 2 terms added together. So although these expressions look intimidating and it can be kind of confusing to know what you're supposed to plug in where, evaluating these difference quotients starts with remembering how to do function evaluation. So whatever my input is, my output is some operation applied on that, whether it's multiplying by 3, squaring, or any other operation that we may see. After that first step, we just need to rely on our algebra skills to remember how to factor different things, how to simplify different things. And our goal here is always going to be to find something to cancel with that denominator. So I'm going to highlight those steps in blue. So remember that each of these steps, our last step was finding something that canceled out with that denominator. And like I said, this is always going to be the case, that we're going to find some term in our numerator simplify our numerator so that we have something that cancels with our denominator. Okay, so this is a brief review on how to evaluate functions and kind of motivating why we need this in calculus and how you'll use it later on. But we hope this helps, and good luck.